Welcome to Study Loop.
We can start thinking that the current is going from left to right, and if that's the case, then the voltage drop or the voltage across this 4 kilo ohm resistor will be given by Ohm's law, which is V equals I times R, and in our case, I is 3.1 times 10 to the power minus 3 amps, and R is 4 kilo ohms, so that's going to be 4,000 ohms, and that gives us the voltage across these 2 points is 12.4 volts. Now, since this this resistor is in parallel connection with 4 kilo ohms, so that means the voltage drop across this guy will be same, and then we can actually find the current that's going through this part of the circuit, and that's going to be I equals V over R. Now V is 12.4 volts and R is 8 kilo ohms. So that's 8,000 ohms, and that gives us the current as 1.55 times 10 to the power minus 3 amps. So that means this current, so let's actually, this current is going through this part of the circuit, and this current is going through this part of the circuit. So if we add them, we'll get the total current that is passing through this battery. So the total current will be the addition of these two. So that's going to be 4.65 times 10 to the power minus 3 amps. So we call it I total. And and as we said that we fix the direction to be from left to right, and so now let's apply Kirchhoff's loop rule here and take the direction as clockwise. If we do so, then this guy will be positive because there's a voltage gain, so it's going to be VBA. Then these two will be negative and this one will be negative as well because they're all in the same direction. And for this part, it's going to be negative because there's a potential drop because it's going from positive to negative, and this will be negative as well. So let's write that down. We'll have 3200 ohms times I total minus 12.4 volts minus 12.0 volts minus 1.0 ohms total. Now, you could see one thing that we didn't actually consider two separate loops here. Instead, we actually replaced the whole thing with the total voltage. Now, the reason we did that is because if we have separated them in two different loops, then we would have gone through the calculation twice. So instead, we can simply write the voltage instead of writing two separate equations. So that's why we have 12.4 volts over here. Right, and if we solve for it, so we know all the all the numbers here. So that means our voltage is gonna be 39.28 volts. Now the second possibility is when the current is going from right to left. So let's actually change the direction from here. So now we have a current that's going from right to left. So that means the only thing that will change here is the uh, this one, because now the current direction is this way, and the total voltage, the sign will change here, and the sign will change here as well. So let's write that down. So for case 2, let's write that case 1. Case 1. Yeah, so for case 2, we have VAB plus 3200 ohms times I total plus 12.4 volts. So there's a change in sign, Then there's negative 12.0 volts, and then 1.0 ohms times I total. So there's another change in sign over here. That's going to be 0. So from here we get our VAB as minus 15 volts. So that means we assume the current is to the left, and that gave us the voltage as terminal voltage as minus 15 volts. Thank you.